Hey everyone. Um, Hope yesterday went well. Do apologize for any bit of craziness, but it's crazy at the house here. So today you guys are learning about cone. So having
Um, Rectangular prism, not too much to add. Pretty straightforward formula: length times width times height. 420. Yesterday you guys did cylinders. It's just a prism with a circle base. So a really nice formula for a prism. Any volume is area of the base, which for a cylinder is pi r squared, times the height. So very nice formula to work with. I got about 2,826. C is a triangular prism. The base is the triangle. Remember, the base of a prism is like the pair of identical sides. So these two front and back triangles form the base. For a prism, we find the area of the base, which in this case it's a triangle. Base times height divided by 2. I got about 8.4 meters squared. And then we take that base area and multiply it by the height of the prism, that length connecting the two identical bases. And here that's 12. 8.4 times 12, I got about 100.8 meters cubed. Some of you guys may have used this formula on your formula sheet, where B refers to the triangle base, L refers to the height of the triangle base, and H refers to the height of the prism. If you use that formula and you got 100.8, then very good. Lastly, for D, we have a pyramid, and for a pyramid, the volume is the base area times the height, much like a prism, but we divide by 3. We looked at that earlier last week. In this case, we have a rectangular base, area of 24 centimeters squared, 6 by 4. The height of this pyramid is 10. Area of the base times height divided by 3 gives us 80 centimeters cubed for that volume. So hopefully you did well on those. Pause the video if you need to ask a question or get something down or clarify something. And then we're going to move on to the volume of a cone. All right, so if you guys remember back to when we did pyramids, we did an experiment with the quinoa we dumped, and you don't need to copy this down, but we took a pyramid scoop and we dumped that into a prism cup, and they had the same area of the base and they had the same height, and we looked at how many scoops did it take to fill. I want you guys to predict if we repeat that process, but instead of a square base pyramid, we use a circular base pyramid, which we call a cone. How many times do you think it would take to fill that circular base prism, a cylinder with the same base and the same height? So take a moment to make your prediction, and then you guys are going to watch a little YouTube demonstration on this. They're actually going to fill a cylinder up, and then you're going to comment on
your prediction, and we're going to derive the formula together. So you can pause the video, and the link should be on my website. You guys can watch it now, and you can bring it back when you're done. Continue.
So doing this on your note, how many scoops did it take? It took 3 scoops. Just like the last time we did this demonstration, which makes sense because a cone is just a circular-based pyramid. A cylinder is just a circular-based prism. So it's the same experiment. Should have taken 3. So what does this mean in terms of the volume of a cone? This means that the volume of the cylinder is exactly 3 times the volume of the cone. And doing a bit of rearranging there, the volume of the cone is the volume of the cylinder divided by 3. Well, we already know how to find the volume of a cylinder, right? It's pi r squared times h. The volume of a cone, pi r squared times h, just divided by 3. So a nice little formula to work with, and we've now kind of shown where it's come from. So on your note, that is the formula for the volume of a cone. We're going to do a couple of examples together, and then you're going to get on to some practice. So first example, just make sure you guys can see here. Yep. Our first example is fairly straightforward. I'm just drawing what you guys already have on your sheet. Very rough sketch. We have a cone. It has a radius of 4 meters. It has a height of 13 meters. We're just going to apply our nice shiny new formula. Volume equals pi r squared h divided by 3. Plug in what we know. 3.14 times 4 squared times 13 divided by 3. And this is actually pretty straightforward to do in one step on your calculator. If you're using a scientific calculator, take a moment, try it on your own, whichever calculator you are using, but make sure you get 217.7 meters cubed. Or if I made a mistake, make sure you talk about that as well, but I think that's good. As you can see, pretty nice formula to work with, nothing too crazy. Since you did cylinders yesterday, cones are much the same. Oh, and there's the phone. Lots of happenings in my house. I'm just going to keep this rolling actually because I don't want to stop it. I'll be back in a second. Hello?
All right, so hopefully you guys can just fast forward to this new point. Anyway, no point apologizing. Just the way it is when your wife's just about to give birth. You guys can chip away at the second and third examples. You can pause the video, try those on your own, and then in a moment, maybe 5 minutes to give you a chance to try those, you can unpause the video and we'll take those remaining 2 up. So you can pause it now and we'll take those up in a second.
Okay, so for B, the twist on B is that you're actually given the diameter of this cone. The radius would therefore be 5 meters. And then you guys proceed as normal. Volume pi r squared h over 3 for a cone. 3.14 times 5 squared times 9 divided by 3.
And I got 235.5 meters cubed. And for our last one, little paper cup that you might see at, say, like a water dispenser. So you guys should just draw it as well. Height of 10 centimeters. Radius of 4 centimeters. Calculate the volume really quick, and then talk about how many milliliters that is equal to. 3.14 times 4 squared times 10 divided by 3. I got about 167.5 centimeters cubed. Now, when talking about volume and out buying stuff, like on bottles and cans, you guys never really see the units of centimeters cubed. Instead, you guys see the units of milliliters. And actually, 1 centimeter cubed, a cc, a cubic centimeter, is actually equal to 1 milliliter. So this paper cup holds roughly about 167.5 milliliters, roughly about like half of a can of pop. So hopefully everything went well with the video. Apologize for the little interlude there. And you guys have some cones practice to work on. We are just looking at volume of cones. We will not be doing surface area of cones. And I believe we have some extra cylinder practice for you to try as well. So good luck, and we'll hopefully see you guys soon.